Hello fellow CNC nuts and welcome. In this episode we're revisiting an old project, the vacuum table. It's one of my more popular videos and certainly the one I'm getting the most questions about at the moment. How's it going? What would I do differently if I was to build it again? Can I have the plans? What's the average airspeed velocity of an unladen swallow? Sorry, wrong movie. So in this episode I'm hoping to answer those questions. And the first one, how's it going? It's not. The problem isn't the table itself, it's actually the vacuum cleaner hose that plugs into it. I made it for a very specific vacuum hose and unfortunately it broke. Since then I haven't been able to use it, but up until that point it was working well. So this time I've gone out and brought myself a new vacuum cleaner. I've brought myself a wet and dry vacuum so that it has its own separate cooling, and I'm going to be adapting the table to plug into it. I'm also going to draw from my experience of building the last one and hopefully not make the same mistakes. But there are some questions I still don't know the answer to, so I hope to also be able to do that with this project. For this project I'm using 19mm melamine coated MDF. The melamine coats the top and bottom to provide a perfect seal, and around the edges I'll apply paint to complete the seal. I start by machining an 8.5mm hole in the corner of the board and check it with a bolt to make sure the sizing is correct. There will be 4 of these holes on the board, one in each corner, to secure the board to the table using the existing T-slots. I then machine 6 holes into the surface of the board. These I'll be using to secure the top plate to the bottom. I then machine a groove into the board 6mm wide, 4.5mm deep. This is done to accept a 6mm round rubber seal that will seal the top board to the bottom. I then change the cutter to a 1/2 inch 90° V-bit and countersink the 6 holes used to secure the top to the bottom plate. I change the cutter once again, this time to a 1/4 inch down cutting spiral bit. I'm going to use that to cut the grid pattern for the table, and it's about now that I realise that the vacuum isn't working as it should do. While it was machining I used the opportunity to check out what was going on with the dust collection. I found that the dust collection drum was full and it started overflowing into the dust collector bag. After emptying the drum and the bag, the dust collection started working again. Now the dust collection doesn't remove all of the dust, just a vast majority of it. With the grid pattern now machined into the material, I now proceed to pocket out a triangular area. This is where the vacuum will be introduced into the table. I then use some of the holes I previously drilled to screw the board down to my tabletop. This is to ensure it doesn't move when I do the final profile pass. Now unfortunately I managed to lose all the footage with cutting out the final shape of the vacuum table. I'm afraid we're just going to have to grin and bear that, but of course that doesn't answer the major questions like, what colour should I make my vacuum table? Well, I can link you in on that secret. It's half truffle. I've now attached the new vacuum tabletop down onto the CNC using the holes I provided on the edges here and the bolts. They go into the T-slots on my table and hold it securely in place, just the same as my previous build. Unlike my previous build, instead of screwing the top piece down, I'm going to use these here. Now these are threaded inserts. They have a 6mm thread on the inside here and quite a coarse thread on the outside. It requires an 8mm hole, which I drilled when I machined it, and I also countersunk it. And there are 6 of them around the table. To install them, all you do is simply put them on the end of an Allen key, put it in the hole, align it up, and let the thread cut its way in to the MDF. It's really very simple. Once it's screwed in, it should be sitting below the surface of my melamine. Next, I have the groove running around the outside, and for that I'm going to use this. This is quite a soft O-ring type foam rubber. It's a bit harder than foam. I picked it up when I was in Christchurch about a year ago. I then proceeded to lose it, which is one of the reasons it's taken me so long to get this video done. Now it just simply slots into the groove I made here. Now this groove is 6mm wide to match the 6mm O-ring rubber, and I've cut it 4.5mm deep. That's going to leave 1.5mm of rubber sitting above the surface. I'm just putting the rubber into the groove, and I'm not stretching it as I go. I just want it to fit nicely, and hopefully I've got the right amount. Just a fraction short there. Just going to stretch. I'll just stretch it around here a little bit, like so, and that's it. Perfect. Now when it's in like this here, if I take a piece of melamine like this here and just sit it on top, there's a small gap between the bottom and the bottom of this piece here. If I push down on it, it comes down nice and flat. So once the vacuum applied, it will pull it down and seal it off very nicely. Now one of the problems I found with this foam is sometimes it has mangled pieces in it, like this here, or like this here. It's got big flat spots in it. Really it's not going to give you a good seal as it goes round, but there's no problem with that. The trick is to simply cut it where you've got those pieces. Doesn't matter whether it's in the middle or on the ends. And I found the best tool for that is actually these here, a pair of side cutters or pliers. Just cut it like that. I did originally try using a sharp knife, but I found these here work the best. Then using some super glue, you can simply glue the ends together, and there's about 2 joins in this material that I put in here. Once it's all glued together, it'll basically be one continuous piece. So don't worry if you've got something like this in the middle of your rubber. You can cut and simply join it in. So it's not just my commitment issues to holding on to O-ring rubber seals that's held up this project. The other is, how am I going to seal this piece to here? Bearing in mind that I made a bit of a complex setup here, this here forms a bridge in which the air passes underneath and into the chamber here. And if I cut my O-ring groove in here, it's going to cut right through the bridge because there isn't a lot of material there. It just wouldn't work very well. I suppose I could have just cut the O-ring groove into here. Why didn't I think of that? Well, it's too late now. Well, actually, I suppose that would mean you've got to double-side this project, and if you do that, it just makes it that little bit harder. Not everybody's comfortable with double-siding their projects. But I have come up with a solution. If I make this and this all in one piece, then I don't need to come up with anything complex at all. It can be kept nice and simple, the O-ring can still do its job and seal the whole piece, and it makes the whole project easier. So with that in mind, let's start machining the top piece. This video is sponsored by Masso's CNC controller. Masso can run mills, lathes, routers, plasma machines, and more. Simply connect your stepper or servo motor drives, a monitor, keyboard, mouse, and pen drive with your G-code. No PC required, giving outstanding reliability while eliminating driver and motion card compatibility issues. Masso, the PC-less controller. Powerful, stable, guaranteed. I start with a piece of 18mm MDF, and using a large diameter cutter, I skim 1mm of material from the back of the board. This is to remove the compressed area and to open the pores in the MDF up to allow vacuum to flow through. Any area that doesn't get cut on the back, I simply remove with a chisel to ensure that it's entirely flat. I then flip the board over, and using the same cutter, I remove the compressed layer from the area that I will be putting my stock to be vacuumed down. I then change to a 90-degree V-bit and create 6 countersinks and a beveled edge for what will become the vacuum intake hole. I change the cutter one last time and drill the through holes into my countersinks. I then pocket out the vacuum intake port and finally cut the top plate to its final shape. I've now been around the outside of my board and I've painted the edges to seal them. And I have here the board that I just finished machining up. I can sit it on top. I just need to line it up so that these screw holes here match the threaded inserts below. I've got here some 6mm countersunk screws, and they will just go in here. Now unfortunately I only brought 4 of them because that's all I originally planned to put in, and I decided to put these ones in at the last minute. So we'll just quickly screw these ones here in place. And I'll just grab a couple more tomorrow when the shop's open. Now we need to be able to introduce the vacuum into here, and for that I picked up one of these here. It's basically just a pipe plumbing fitting and it just fits in here like so. Now the reason for the V around the outside was if this is not a tight fit, then I could put some sort of a sealer in here which will help seal this. However, this is actually a pretty tight fit, and I've got here a clamp which I can screw down into here to hold this in place. Now some of the attachments that came with my new vacuum is this here, a little rubber fitting to adapt it to various tools for dust extraction, and a small hose which you can plug into the end of your vacuum hose. So I'm just going to plug this in here, and it's just the right size for it. And then this end plugs into the end, or just over the end of the vacuum hose. I hadn't really expected these accessories to come with it, but I'm really pleased that they did. Okay, well now we can turn on the vacuum. And there it is, it's running full power. Let's just quickly remove this and see what it sounds like. Unplugged, which means it's actually pulling air through here, and I can actually feel air being dragged through this here. So let's just take a piece of board and I'll just cover a little bit of my table. Let's see how easy it is to remove. There's a little bit of suck there. It's not overly hard to remove, but let's now try and pull it towards me and see if I can make it move. No, I actually cannot budge that. There is too much force in the sideways direction. Now this vacuum actually has settings on it, and I can actually set it down to maximum or minimum or anything in between. So this is the minimum vacuum that the vacuum cleaner will pull. I can still feel air pulling through this section of the table. Let's see how well stuck this is now. I can make it move just a little bit like that. It's easy enough to lift up, no problem. No problem if I want to lift it. But certainly even at the low pressure from the vacuum cleaner, there is no shortage of sideways force coming from this table. Okay, well so far I'm liking what I see. It's a nice clean design, low profile here for the hose. I can attach the vacuum to this one here, which is a vast improvement. And it seems to have plenty of holding power in the sideways direction. However, I'm not quite that keen on the amount of vertical holding power that the table seems to have. Now if you recall, on my previous build I used a sheet of newspaper to go between the surface of the table and the material. And when I did that, I got a vast improvement in performance out of it. So I have here my favourite publication, strong, soft and thoroughly absorbent. I'm going to put that on the table and put my stock on top. Let's turn on the vacuum and see how it behaves. Paper's not holding as good as it does on my other table. So as you can see, the paper really wasn't sucking down to the tabletop as you'd expect it to. There was certainly plenty of sideways holding, but again it was very easy to lift the material off the surface of the table. But is there room for improvement? In the next episode I'm going to investigate that. If you remember my previous build, I had a series of holes all along the tabletop there. So I'm going to duplicate the same. I'm going to make a new tabletop, put pockets in the top, and we'll see what effect that has. All that remains me to do is to thank you guys for watching. Don't forget to like and subscribe, and I'll catch you guys later. Cheers! For those of you who have stuck around this long, here's the first project I cut on my new vacuum table. I found I had to run the vacuum at 3/4 power, otherwise it would get too hot. But at 3/4 power, it was running about right. The project took an hour to cut, and there was plenty of holding power to hold my board down to the table. I still think there's still improvements that I can get, and I think I will be able to get a bit more downward force on it. But until I test out that whole theory I've got, I'm not going to know. We'll just have to find out in the next episode. Thanks for watching, and I'll catch you guys later. Cheers!